Main chain and methyl groups is the first section we'll start out with in this unit. Because of the unique property of catenation and isomerism, carbon forms a large number of organic compounds. Catenation refers to carbon's ability to form chains. So the ability for carbon, multiple carbon chains to form is really important to the varying properties of carbon compounds. Isomerism refers to the different hydrocarbons that exist with the same chemical formula but different structures. And we'll look at plenty of those, but there are lots of carbon-hydrogen compounds that have the same number of carbons, the same number of hydrogens, but those are connected and arranged in different ways that then give rise to a different structure that has different function. There is a systematic nomenclature called the International Union of Pure and Applied Science, abbreviated IUPAC, that was adopted to provide a consistent naming scheme for organic compounds. Let's talk about the importance of this naming system that we're going to be learning. We know of more than 20 million carbon compounds. Researchers around the world actively study many of them. A common naming system is necessary so that scientists are able to share their results and for science, engineering, and medicine to continuously progress. IUPAC, or the International Union of Pure and Applied Chemistry, provides that system, and that is a system that we're going to be learning. All right, let's talk through this process of how we name alkanes. The first thing we have to do is find the longest continuous chain of carbon atoms. That chain determines the root name for the hydrocarbon. When naming parent alkanes, that's the portion that belongs to the linear sequence, that chain that we found, beyond butane, we add the suffix ane to the Greek root for the number of carbon atoms. We'll look at this in much more detail, but let's just look at the example that we have here. The longest chain here is 6 carbons. So the parent alkane is, the prefix for 6 is hex, and then we add the ending ane, hexane. As a reminder, these are the first 10 main chain alkanes. The first 4 don't follow their prefixes. 1 carbon methane, 2 ethane, 3 propane, 4 butane. But then after that, we get the Greek prefixes: pentane, hexane, heptane, octane, nonane, and decane. They are named based on the number of carbons. These are the names used to name the parent alkane in a molecule, which will be what we call the root name of the molecule. The parent alkane, as we discussed in the previous slide, is the longest chain of carbon in the molecule. Let's talk now about substituents. The term substituent refers to the portion of the molecule that is not part of the longest chain of carbon atoms. In the example here, we have the same parent chain that we had on the previous slide, our hexane, our 6 carbons. But shaded in this green color here, a CH3 has been substituted for a hydrogen to create what's known as a branched alkane. When naming branched alkanes, we would drop the ane, that would be a part of this normally named 1 carbon alkane, right? And add YL to the Greek root for the number of carbon atoms. So what that means is 1 carbon we would normally name methane, right? But when it's branched, instead of ane, we would call it methyl. We would add YL. Okay, so this is a methyl group substituted on this parent carbon chain. We're going to start out with some simple branched alkanes. This table shows the first 2 substituents that we will be working with. These branch alkanes are not part of the main chain. They're not part of the longest chain of carbons in the molecule. The open end with the bond indicates the connection point to the main alkane. So we could have a methyl group that has one carbon, and of course this bond would connect to the main parent chain. An ethyl group, remember ethane would be a 2-carbon chain. An ethyl group would have 2 carbons, and at this bond right here would be connected to the parent chain. The first step we take in naming a molecule, the most important step we take, is in determining the main chain. We have to first find the longest continuous chain of carbon atoms, and it's not always as straightforward as just looking at the molecule and seeing how it's drawn to find the longest chain. The only way to determine it is to count the carbons in each possible chain to determine which one has the highest number of carbons. Carbons are in the chain if they can be connected without backtracking. So pick one end and count forward the longest chain you can. For instance, can you see 2 possible main chains in this molecule? Try and see if you can't number or count those carbons here. And on the next slide, we'll take a look at the details. Okay, so highlighted in blue on the same molecule are 2 possible different main chains. All right, so here in a straight line, I have 1, 2, 3, 4, 5, 6. Or bent here, I have 1, 2, 3, 4, 5, 6. Okay. Each chain has 6 carbon atoms, so they're the same length. So either could be the main chain. Our choice will not affect the resulting name of the molecule. Once the main chain is determined, the carbons are numbered so that the name of the molecule can reflect where the substituent or substituents are located. Numbering begins with the end carbon nearest the substituent. So I could start numbering where you see in blue here, or I could start numbering where you see in orange here. In this case, if I start in orange, the substituent is 1, 2 carbons from the left side. And if I start from the right in blue, then I'm 1, 2, 3, 4, 5 carbons from the right side. So we start numbering from the orange side, since this end is nearest to the substituent in green. We do not number from the right side here in blue because that end is further from this substituted group. All right, this is the same slide with the same molecule. I've just added in purple numbers, starting with 1 on the left side all the way to 6 to number that parent carbon chain. So we have a 6 carbon chain starting with the 1 at the left. Once we've determined the longest carbon chain, we use that number to give the molecule its root name. In this case, there are 6 carbons in the longest chain, and so a 6 carbon chain would have the root name hexane. Then what we do is we look for substituents, and the names of the substituents go in front of the root name, and they include the number, which carbon number they are bonded to. So in green here, we have a methyl group bonded to the 2nd carbon in the chain. So we would name this carbon molecule, this alkane, we would name it 2-methyl hexane. The 2 is the number of the carbon to which this methyl group is bonded, and the main chain is hexane. In the next several slides, we're going to work through this example. We have a molecule here that we need to identify and name. So we're going to first identify and name the main chain. Then we're going to identify the number of carbons, identify the name of the substituents, determine the bond to which the substituent is bonded, and then finally name the molecule. On this slide, try to work with a partner or with a group to name this, and over the course of the next several slides, I'll go through each part individually. The first step is to identify and name the main chain. So you see highlighted in blue the longest chain of carbons that you can find is 6 carbons long in this case, and so we name it hexane. Now, we could have tried to make a chain with this carbon, but let's say I started here and I counted 1, 2, 3, 4, 5, or 1, 2, 3, 4. Neither of those chains is the longest chain. So what we've highlighted in blue is the longest chain. We call that the parent chain or the main chain. And because it is 6 carbons long, we name it hexane. Once we've identified the main chain, we need to number the carbons. And so here's what's important. We can number from left to right or from right to left. So we can start here, 1, 2, 3, 4, 5, 6. Or we can start from the other end, 1, 2, 3, 4, 5, 6. The numbering begins from the end carbon nearest the substituent. So here's our substituent, circled on this carbon right here. That's where it comes from. We need to start our numbering from the left because that makes this 1, 2, 3. Carbon 3. If we start on the right and go to the left, then we get carbon 4. So we number from the left. All right, so you can see in purple, we've started our numbering. 1, 2, 3, 4, 5, 6. In the next slide, we will identify and name the substituent. Remember that substituents are branches that come off of the main chain that are substituted for a hydrogen. So in green, I've highlighted our substituent group, and it's only 1 carbon. And we would call a single carbon hydrocarbon alkane would be methane, right? But we drop the ANE and we say methyl, ending in YL. So this is what we call a methyl group. Step 4 is to determine the carbon to which the substituent is bonded. So if we did all these previous steps properly, all we have to do is just look and see what number is this. So circled in red, you can see this is carbon 3. The last step is to name the molecule. So we start with our substituent. So we know we have a methyl on carbon 3. So we would say 3-methyl and then end the name with the parent group, which is hexane. So we get 3-methyl hexane. All right, here's a second example. We have this carbon chain, this alkane. We're going to identify the main chain and name it. We're going to figure out the number of carbons, count them, number them, identify and name the substituent, and determine the carbon to which the substituent is bonded. And then finally, name the molecule. So just like we did in the last example, try to do this on your own first if you can. Try to identify the main chain and the substituents and all of that, and then I'll go through each part in the next slides. All right, so you can see highlighted in blue the main chain, and it is 6 carbons long, 1, 2, 3, 4, 5, 6 carbons long. I want to point out that we could have labeled this differently. We could have gone 1, 2, 3, 4, 5, 6 to find the longest chain, and we still would get hexane, okay? Or we could have started here, 1, 2, 3, 4, 5, 6. The only one that's shorter is this 1, 2, 3, this one here. So as long as we find the longest chain we can, it doesn't impact the final name. Okay, we just gotta find the longest chain. So the longest chain, whether you choose this one or whether you choose an L-shaped chain, regardless, it is 6 carbons long and therefore has the name hexane. All right, now we need to number those carbons. So it's 6 carbons long. We could start on the left, which is what we've seen in all of our previous examples, and how we're used to thinking and seeing, numbering is going from left to right. So we could start here and say 1, 2, 3, 4, 5, 6. Or we could start from the right and go towards the left. 1, 2, 3, 4, 5, 6. So remember that we have to start from the end nearest to the substituent. And so that would be starting from the left, because the substituent carbon is here circled in red. And so we get 2 from the right or 5 from the left. So we need to start from the right, start numbering 1, 2, 3, 4, 5, 6. So we'll number those and show it on the next slide. All right, here you can see indicated in purple the numbering of the carbons. 1, 2, 3, 4, 5, 6. The next step is to identify the name of the substituent. So the substituent, remember, is something that's substituted for a hydrogen off of the main chain. And we can see highlighted in green, we have a substituted group, a substituent group. It is 1 carbon, so we call that a methyl group. All right, so we identified and named the substituent as the methyl group, indicated in green. All right, next step is to determine what carbon the substituent is bonded to. So you can see in red here, this substituent group is bonded to carbon 2. And the last step will be to name the molecule. All right, so now let's finally name the molecule. So we know we start with our substituent group. So we have a methyl group on carbon 2. So we start with 2-methyl, and then the name of the parent group, hexane. 2-methylhexane. You can see I've flipped it. I've just flipped this so that carbon 1 is on the left. And now this is exactly the same molecule that we began with this in the unit, just simply drawn differently. And the reason for that is just to say we have to make sure that we're doing this step 1 first. We have to find the main chain by counting the carbons, and the direction that we start from and the way that we go from there can't just easily be predicted. We just have to count them from the left, from the right, and find that longest chain. All right, in example 3, let's work together through each of the steps. So first, let's identify and name the main chain. So remember, the goal here is just to find the longest number of carbon atoms in a row that you can find. So let's try to circle that together. So if I start here, 1, 2, 3, 4, 5, 6, then I can actually go this way, 7. So there's 7 total carbons in my chain there, and we would call that heptane. Heptane. So as a reminder, if you can connect the carbons without lifting your pencil or backtracking, they're all in the main chain. In this case, all 7 carbons are in the main chain. So we call this heptane. Then we're asked in the next step to number the carbons. So let's do that together. I can start here and say 1, 2, 3, 4, 5, 6, 7, or I could do the reverse and say 1, 2, 3, 4, 5, 6, 7. The larger question is which one is right, or does it matter in this case? All right, so you can see the carbons numbered in purple, similar to what we had on the previous slide. In this case, since there is no substituent, right, all we have connected to these carbons are hydrogens. The carbons can be numbered from either end. So how we had it on the previous slide where I also started here with my 1, that's also correct, but all 7 carbons need to be numbered. Now, step 3, identify and name the substituent. Well, we've just discussed there is no substituent, right? There is no substituent, so I'll just put none. And then determine the carbon to which the substituent is bonded. Well, there is no substituent, so this is not applicable. This step doesn't apply here. So from here, can we name the molecule? Well, if there's no substituent bonded to any of the carbons, then our molecule name is simply the name of our main chain. So this is heptane. Since all the carbons are in the main chain, every carbon is in the main chain, there is no substituent, and so the name of the molecule is the same as the name of the main chain. In this case, heptane.